Linear relationships. This is point gradient equations. Finding the equation from the gradient and a point. Now sometimes we're given an x and y intercept. We saw a video on that recently where we can find the equation from having a y and an x intercept. Now here we've just got some limited information. This is asking us, for example, to find the equation of a line with a gradient of 2 and if that line passes through the point 1, 6. So we've got limited bits of information. Let's see if we can piece together a linear equation from just those little snippets of information about the line. Okay, so y equals mx plus b. We know the m talks about the gradient and the b is the y-intercept section of that. So let's have a look. First of all, we'll substitute all the values that we have in the question into y equals mx plus b and see where we are then. So we're going to put all the numbers in there. Now our x value, you can see from our point, is 1 and our y value is 6, and we also have a gradient given to us of 2. So that's our m, that 2. It's a plus 2 as well. And so let's substitute those 3 bits of information into our equation format here. We're going to replace y with our 6, and we can replace our m with a 2 and our x with a 1. So we're just using the information from the question over here. We're putting that into that y equals mx plus b format. And we're going to replace x with a 1 here. Okay, then see where we are then. Now m is beside x here, so we know from our algebra there's an invisible multiplier we can consider to be between those two numbers. So let's just simplify that just a touch further here. We'll get 6 on our left hand side. We'll get 2 from 2 times 1 there, and all we're left with is those numbers and b. Okay, so if b is the only thing left to find out to create or to discover a linear equation, let's find that b out. So our next step is to solve to get b on its own. So what do you think we might have to move to get b on its own? I think we might have to move that 2, really. Now that's a positive 2, so you'll remember from solving equations that we have to do the opposite to both sides. So to move a 2, we'll have to subtract 2 from the right hand side, and whatever we do to the right hand side of an equation we have to do to the left hand side, don't we? So we'll subtract 2 from both sides with the aim of getting b on its own. Now on that right hand side we have a plus 2 and a minus 2. They can cancel each other out nicely. That's great for us because we wanted b on its own all along. And on the left hand side we'll just calculate 6 minus 2 equals 4. Now if 4 equals b, of course we can just swap that around, b equals 4. Now we had pretty much information, great information about everything really now, now that we've discovered b. So let's piece together the linear equation. Y equals, step 3 is to write the final version of y equals mx plus b. Now our gradient was 2. And our y-intercept, our b, is 4. So that's pretty much all we need to write the final version out here. Y equals mx plus b. Let's put our m of 2, so we'll replace our m with a 2. And we have a b value over there of 4. So let's replace our b with 4. And we've compiled a linear equation of y equals 2x plus 4. So let's recap there. We substituted all the values into y equals mx plus b that we could from our question. We had a y value from the point, we had an x value from the point, and we had an m that was given to us in the question. So once we substituted all that in, we just had to find b. We had to rearrange the equation to solve it, to get b on its own. And then once we had m from the question and b from our working out, we could piece together the y equals mx plus b final version as step 3 there. So that's how we find an equation from a couple of snippets of information. We had the gradient and a pointer that it passed through, and so we're really basing this on that idea that if you know that a line passes through a certain point, the coordinates, the values of x and y from that point make the equation work properly, so we can kind of trust the values there that they'll make the equation work properly, and we use that fact to piece together a linear equation from just a couple of small bits of information. Okay, so our final equation was y equals 2x plus 4 there. Thanks for watching. PeterBlakeMaths.com for all your video instruction needs. See you next time.